Okay, Pure 1, Chapter 6, Trigonometric Ratios. So today, really nice and simple chapter, okay? You're going to be able to use the cosine rule to find missing angles and lengths, the sine rule to find missing angles and lengths, use the area of a triangle, half AB sine C, and then we're going to be sketching sine, cos and tan and using simple translations. And then we're going to be solving a problem with those. Again, this is pretty much GCSE with a slight bit of extension. So, sine and cosine rule, GCSE, okay, but this time what we might do is incorporate a few bits of algebra instead of just numbers, okay, but it's the same application. Areas of a triangle, again, you know, instead of always, you know, we'd have to draw the triangle, find out which values we need, maybe use the sine rule as well as the cosine rule, find the area, so half AB sine C, and again, it will be problem solving, so it's, you know, it's just a bit more challenging than GCSE. And then we're going to be sketching graphs, not only sketching them, but solving simple sine, cos and tan equations using the graph and symmetry. Okay, so that is slightly new. We're going to look at that towards the end of the chapter. So then, very quick recap. We should be, if I see a right angle triangle and I'm looking for an angle, the first thing that should come into our heads is SOHCAHTOA. So we should all be happy with SOHCAHTOA. And if we're going to find x here, we know we have the hypotenuse, opposite, adjacent. Okay, what do we have? A, what do we want? H, O is nothing. So we're going to be using cos. So we know cos of 20 equals 4 over x. Okay, rearranging equations, we're going to get x equals 4 over cos of 20. We're going to put that into our calculator, get an answer. For the next one, we want to find the angle. So we know we've got our opposite, hypotenuse, adjacent. Okay. Our hypotenuse doesn't have anything, so it doesn't matter. We've got O and A, TOA, so we've got tan of our angle theta equals O, which is 5 over 3. To find the angle, we know in our calculator, we're going to use tan inverse, which is tan to the minus 1, 5 over 3, okay? So, just for your interest, have you ever wondered why cosine contains the word sine? It is the complement of sine, and absolutely, it's also a translation of the sine graph. They are linked very heavily, okay? And we will read up more about that. You know, if we think about complementary angles, one complements the other. So then, we have an overview. There's pretty much 4 rules. Now, I don't really like to talk about rules because we need to have an understanding, but this is going to help you. So, if we do not have a right angle triangle, we cannot use SOHCAHTOA. We have to use either the cosine rule or the sine rule. So, there's, in theory, 4 types of questions that are going to come up, okay? And you have 2 angle side opposite pairs. Okay, so what this means is you have an angle here, and opposite you have the side, and you have the angle here, and opposite you have the side length. If we have that, we're going to be using the sine rule. Okay, now for the next one, you have 2 sides known and a missing angle opposite. 2 sides known and a missing side opposite a known angle. Okay, so in this case, you have an angle in between 2 sides and you want the missing side. We're going to be using the cosine rule. Okay. This time we have all 3 sides, but we want to find the angle. Okay. We are going to be using the cosine rule, rearranged. Okay, still the cosine rule. Then we have 2 sides known and a missing side not opposite a known angle, and we want to find the remaining side, okay? So this is the other type. So we have an angle opposite, okay, which is fine. Then we don't have another angle. So what we actually have to do is we have to use the first one, okay, to find this angle. We know angles in a triangle add up to 180, so then we can find this angle, and then we can use the cosine rule. So in this one, you have to use the sine rule first, then the cosine rule, okay? So, yeah, you could use the sine rule twice. Ah, so you wouldn't even, so there's two ways. We could use the sine rule and the cosine rule, or the sine rule and the sine rule, okay? Either way will get you the same answer. So, the cosine rule. Those of you who know how to use the cosine rule, I would like you to try and prove it, please. Okay, so when we look at the cosine rule, normally it has a squared equals b squared plus c squared minus 2bc cos a. We see this angle cos a, okay? We label angles in capital letters and we label sides in lowercase letters. Because it said cos a here, we know that this is angle A. Okay, because this is the angle we only know. Opposite angle A is always going to be our side A, which we write in lowercase, little a. Then the other two sides, it doesn't matter. This could be, if this is angle B, this is the side, little b. If this is angle C, opposite C is the side, little c. Okay? So, now we're going to substitute in. Now we've labelled our sides, we're going to substitute in. So, a squared is x squared equals our b is 12 squared plus our c is 15 squared minus 2 lots of b, lots of c, cos, brackets, 115. Now, a really handy thing is I want you to put this in the calculator. So we're going to get x squared equals. I do not want you to mess around by working out each individual one. There is no point and it is a waste of time. Okay, so you're going to put the whole thing into your calculator, double check what you've written is right, and we're going to get 521.14 blah, 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 blah. Okay? I'm going to keep that in the calculator because I want the square root of it. So x equals the square root of 521.14 blah, 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 blah. So in my calculator, I'm going to do root answer. I do not just put 521. I have to put root answer. And I'm going to get x equals 22.8285. I'm going to round it to three significant figures. And so x is going to be 22.8. Now, the only thing that we have to remember is normally when we square root, we always have a positive and a negative value. We are not going to take a negative value because this is a length, and a length is always positive. So what we're going to do is we're going to label everything. Now, remember, the angle we always label capital A. So here's our angle, we're labelling that capital A. Opposite our angle is this side, which is our lowercase a, and then the rest is B and C, it doesn't matter. So I can just call this B and C. Now, the difference with this question and the question before is last time we were looking for A, the length. This time we're looking for A, the angle. Now, I think in the formula book they give you this formula, but we have to rearrange this formula to find the angle. So, what we're going to do is we're going to rearrange this, okay? And I'm going to teach you how to rearrange this in a moment. But for right now, you need to know that cos A equals, okay, b squared plus c squared minus a squared over 2bc. That is that rearranged, and you're going to prove to me how I've done that. I'm not even going to show you that. You should be able to rearrange this. Okay, so in a minute, you're going to try and rearrange that for me to see if you can get this form. Okay? Now we have our rearranged formula, we're going to substitute in. So we know that cos of our angle, so cos of our angle A equals B squared, 7 squared plus C squared, 9 squared minus A squared, over 2 lots of B bracket C. You're going to put that whole thing into your calculator for me, please. And then we're going to get a value for cos A. Okay, we're not going to waste time working out the numerator and the denominator. You're going to put the whole thing in to get a value for cos A. So, once you do that, you're going to get 19 over 21. And then to find A, you're going to do cos inverse the answer. Okay, so in your calculator, just do shift cos answer. Okay, and we're going to end up with 25.208 degrees. And then to three significant figures, it's 25.2 degrees to three significant figures. So all I did was, if we start with A squared equals B squared plus C squared minus 2BC cos A. What I did was I added 2BC to both sides. Okay, so I get 2BC cos A plus A squared equals B squared plus C squared. I minused A squared from both sides. 2BC cos A equals B squared plus C squared minus A squared. And I divided both sides by 2BC to get cos A. Okay then, so we've got two harder examples. What we're going to do in these examples is I'm going to give you a minute to give it a go. And this time you notice we're not using numbers, we're using algebra. And then I'm going to give it a go as well. Now remember our formula. A squared equals B squared plus C squared minus 2BC cos A. So I'm going to go through the beginning of the first one for us. So step one, we label. Our angle is 60, so that's our angle A. We know opposite is our little a, and then we can label B and C as we see fit. When we substitute in using our formula, so A is 2x minus 1 squared equals our B is x squared plus our C, which is x plus 8 squared, minus 2 lots of B, which is x, lots of C, which is x plus 8, cos of 60. Okay, that is exactly what we should have. Doing this is going to give you method marks, and then from here you should automatically be able to think, right, well, clearly I need to solve this and find x, don't I? I've got everything here that's, you know, put into this form. I now need to expand. So I'm going to get 4x squared minus 4 plus 1 equals x squared plus 16x plus 64 minus 2x squared minus 16x. Okay, but all of that is multiplied by cos 60. Okay, please be really careful here. I'm going to put a plus there and then have this. Absolutely, this is supposed to be minus 4x. I said it, I didn't write it. Okay, now, cos of 60. When I put cos of 60 into my calculator, I'm just going to focus on this part here. When I put cos of 60 into my calculator, I actually get a half. So I'm going to multiply this bracket by a half. Okay, so I'm going to rewrite this again. So I get 4x squared minus 4x plus 1 equals x squared plus 16x plus 64, and then I'm going to multiply minus 2x squared minus 16x by half. So I'm going to get minus x squared minus 8x. Okay, that is what we should have. And even though I would normally simplify some of this in my head, I've done it a bit slow. So now I'm going to simplify everything. And again, I'm going to do this in a few steps. So I'm going to leave the left-hand side as it is. 4x squared minus 4x plus 1 equals x squared plus x squared is 2x squared minus x squared is just x squared. Okay, 16x minus 8x is 8x, and then I have plus 64. I'm going to move everything to the left-hand side. So I'm now going to get 3x squared minus 12x minus 63 equals 0. Now, if I wanted to, I could divide everything by 3 to make it easier. So x squared minus 4x minus 21, okay, equals 0. So that means that I'm going to get x minus 7, x plus 3 equals 0. So x could equal 7 or x could equal minus 3. Now, as we know, sometimes we now need to check these, okay? Now, if I put x equals 7, so the 7 we don't need to really check because it's a positive value and lengths can be positive. With x equals minus 3, if I put x equals minus 3 here, minus 3 plus 8, I still get 5, which is a positive length. That would work. But this side, my x is just x. And this would be minus 3. So it doesn't work. We cannot have a negative length. So we reject x equals minus 3. But please do not just always reject a negative if you haven't tested it into the actual sides first. Because sometimes, okay, when we put it in, for example, on this side it worked. And if all of our equations meant that it would work, it would be positive. If x, was greater than or equal to minus 3, we'd still have positive lengths. Please check. So we need to reject negative 3. So our actual answer is just x equals 7. Okay, so I've got a question here, and as you can see, there is no diagram. Now, personally, as a mathematician, I really like to draw things, okay, to see what's going on. So I'm going to read the question. Coast Guard Station B is 8 kilometres on a bearing of 60 from Coast Guard Station A. A ship C is 4.8 kilometres on a bearing of 18 degrees away from A. Calculate how far C is from B. Okay, so we've got A, B and C, 3 points. More than likely it's going to be a triangle. So I'm going to start drawing my point. Okay, Coast Guard Station B. This is B. Okay, this is my Coast Guard Station. Is 8 kilometres on a bearing of 60 from A. So it's come from A, 80 kilometres at 60 degrees. Now we know that this is 90 degrees, don't we? So 60 degrees is going to be a bit less than that. Okay, and whenever we do bearings, remember we start from the north line. So if you go north, go to 60, it's about there, isn't it? So we know that A is going to be here. This is 8 kilometres. And this here is 60 degrees. Okay? Then it says a ship C is 4.8 kilometres on a bearing of 18 away from A. Okay. So ship C is 18 from A. Okay, so this is our north line, we said, and we have 60 degrees there. And then what we're going to have is A is 18, which is probably about, it's about there, isn't it, 18, if you think from our north line. So C is going to be here, okay, it's 18 degrees, and that is going to be 4.8 kilometres. So what it's actually going to look like is our A, C, B, this is 8 kilometres, this is 4.8 kilometres, and here is, okay, so this isn't 60 degrees, okay? This is 60 minus 18, which is going to be 42. So this is 42 degrees. So now you've done this, okay, you're able to find the rest of the question nice and easy because We just want to know, we want to find here, how far is C from B? We are now able, okay, to use the formula A squared equals B squared plus C squared minus 2BC cos A, okay? So we're going to get A squared equals B squared 4.8 squared plus 8 squared, okay, minus 2 lots of 4.8 lots of 8 cos 42 degrees. So A squared equals 29.966, and then when we square root that, A equals 5.474, and then to three significant figures, it's 5.47 kilometers, okay? What I am going to do is just explain this bearings part again, because I don't think I drew a very good straight line. Right, if A is here, and we think we have our north line A, okay? It says that B on a bearing of 60 degrees, okay? So what I'm actually going to do is I am going to get out a protractor for us, okay? So that we can actually physically see what's going on. So if I put this here, okay, if we go to 60 degrees, okay, so remember when we start, we always start at northward bearings. We go down, if we have a look, 0, 10, 20, 30, 40, 50, 60, okay? So 60, right, this means, oh, how do I move it? Okay, I don't, right, so this is 60 degrees, yeah? Okay, then the other one said 18 degrees. So 18, if I start at 0, go across, 18 is about here. Okay, now what I'm going to do, because I don't know how to, I'm going to delete it. Oh. Okay, right, let's just imagine 60 degrees is somewhere along this blue line, okay? So this blue line, we know from here to here is 60, okay, from bearings. Using our red line, okay, we know from here to here is 18 degrees, okay? Now, it tells us in the question that our B is 8 kilometres. So along this line, if we measure 8 kilometres, wherever we stop, that is where B is, okay? On our red line, because it's 18 degrees, on a bearing of 18 degrees from A, it says it's 4.8 kilometres. So if we measure here, we get 4.8. This is our C. But the actual angle here is 60 minus 18, which is 42 degrees, okay? So when you're drawing these pictures, please make sure you understand what's going on. Okay, so the sine rule is really easy, and this is just using ratio. So we're saying, now we can write it either two different ways. We're saying the sine of the angle A over the length is going to have the same ratio as the sine of the angle B over the length B. Okay, this is the rule. Or we could write the rule the other way. where the length over the angle is the same as the length over the angle. Okay, so either way you can write it. It depends how you're feeling. Depends what you need, okay? But we should be fairly confident at rearranging, switching this around. So it doesn't matter which way we write it. So we know that this is our angle B, this is our length B. And here we have our angle A, we have our length A. If it said find angle A, because we've got opposite matching pairs, okay, the blue are opposite in matching, the red are opposite in matching, we can use the sine rule. Okay, so we want to find the angle, then I want to have the angle as my numerator. So, sine of my angle A over my length, which is 9.1, equals sine of my angle B, which is 30, over my length of B, which is 5.02. So how do I find sine A? Sine of A equals sine of 30 over 5.02 times 9.10. So I'm going to put that into my calculator. And then what I'm going to do, 5.02 times 9.10, okay, is inverse sine. So I get sine of A equals 455 over 502, inverse sine of the answer. Okay, so A equals sine to the minus 1 of 455 over 502. I get A equals 65.009 degrees. If I just keep that, this is 65 degrees. Now, because I already know, angles in a triangle add up to 180. So if this is 65 degrees, and this is 30 degrees, this one is 180 minus these two added together. 180 minus 95 is 85 degrees, okay? So, the next one. It doesn't matter what your A is or your B or your C is, okay? As long as you know, capital letters are used for angles, lowercase are used for lengths. So if I always prefer to use my matching pair as my A, but it doesn't matter, but this is my preference. So this is my angle A, this is my length A, and then I always go to B. This is my angle B, this is my length B. Okay, I want to find my length B. If I want to find length, I'm going to put length on the numerator, because that's personally my preference. So I know my length over sine B equals A over sine A. I'm going to fill out everything that I know. So my B is what's missing. So B over sine 85 equals 8 over sine 45. So to find B, I'm going to get B equals 8 over sine 45 times sine 85. Means my B equals 11.27. Okay, if we're just doing three significant figures, it's going to be 11.3, and it could be centimetres or metres, okay? I'm just going to put here, this is a length, okay? Right, for this one, you can see my first pair, I always call my A, okay? So this is my capital A for my angle, my lower A. Then, the pair with something missing here, well, this is my next pair. So my angle is B, you could have called it C, it doesn't matter, and my length is B. Again, I want to find B. So I'm going to use the exact same method as I've just done then, okay? Okay, the next type of example is where we want to find the angle. So again, My matching pair I always label as my A's. So this is my angle A, this is my length A. My next pair I label my B's. This is my angle B, this is my length B. And you can see we want to find the angle. So I'm going to start with the angle as my formula. Sine of B over B equals sine of A over A. So I'm going to get sine of B equals sine of A over A multiplied by B. Okay? And then what I'm going to do is I'm just going to rub out these little bits and write down what it's supposed to be. So sine of A is 85 over 6 multiplied by B, which is 5. Okay? I then know that when I put that into my calculator, okay, so I've got sine of 85 over 6 times 5, I'm going to get sine of B equals 0.83 something. I'm going to keep that answer so that B equals sine to the minus 1 of 0.83 blah, 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 blah. Okay, but I'm going to do shift sign ants in my calculator so that I do not lose anything. So I'm going to get 56.115. Three significant figures, that's 56.1 degrees. So what I would like you to do is question 5, 6, 7 is you've got to draw questions 5 and 6, you've got to actually draw the diagram to then figure out what angle or length you need to find. And in question 11 and 12, it's a bit more problem solving. Please give them a go. Okay, so I'm reading the question. It tells me this angle is obtuse. I'm not going to worry about that for a second. I'm just going to work out the angle using the sine rule. So I always do my matching pair first. So here's my matching pair. 20 and 5 are a matching pair. Because it's matching, I know I can use the sine rule. And I want to find the angle, so I'm going to put that as my numerator. So I'm going to get sine of my angle theta divided by 10 equals sine of 20 over 5. Okay? I'm then going to get sine of theta equals sine of 20 over 5 multiplied by 10, which is 2 sine 20. Okay, I'm then going to get theta equals sine inverse of the answer, which is about 0.684, blah, 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 blah. In my calculator, I'm going to use the answer button. I am not rounding. Okay, so shift sign ants, and I'm going to get theta equals 43.16 degrees. Okay, now, theta is 43.16 degrees. To three significant figures, I'm going to get 43.2 degrees, okay, to three significant figures. And I'm just going to use three significant figures for this question. It hasn't specified. But hold on a minute. Is 43 degrees an obtuse angle? Absolutely not, okay? Absolutely not. It isn't. An obtuse angle is in between 90, okay, and 180. So we actually need to find the other angle. Now, some of you, if you were in top set GCSE class, you will know about the sine, cos and tan graphs. For some of you, this may be a little bit new. So I'm just going to zoom in here. Okay, our sine graph. Okay, oh, that's a terrible straight line. Okay, so our sine graph is going to look like this. So we can see, and this is what we're also going to be looking at towards the end of the chapter. This is new for some of you. So here we go. Okay. This is 1 and this is -1. This point here is 180 degrees. This here is 90 degrees. This is 270 degrees and this is 360 degrees. We should remember drawing the sine graph, okay? Now we're going to be using symmetry. Whatever our answer was then, if we go back, we know it was 0.684. Well, so that means my y equals 0.6x4 essentially. 0.668 is roughly here, isn't it? 0.6x4. And if I draw a dotted line, I actually have 2 values of x. Okay? Our first value, what was it? 43.2, but it also crosses at another value. Now, because this is symmetrical, what we're going to find is this is 180 minus 43.2, which is 136.8 degrees, okay? So when we're using sine, we can do 180 minus the angle to find the obtuse angle, okay? Well, it might not be, you know. So we're using symmetry, and this is something that's a little bit new that we will go into. So even though our angle is 43.2, the obtuse angle is in fact 136.8 degrees. This is the angle I'm going to use, okay? It then says, given the angle theta is obtuse, determine theta and hence determine the length of x. So if this is 120, this is 136.8, okay? I get 156.8, so this one is 180 minus 156, which is 23.2. Okay, 23.2. So now that I've got this angle, I can use the sine rule again to work out my length of x. Okay then, so let's have a look at question 6. So, if I move this up here, right then, a crane arm AB of length 80 metres is anchored at point B at an angle of 40 degrees to the horizontal A. Wrecking ball is suspended on a cable length of 60 metres from A. Find the angle X through which the wrecking ball rotates as it passes the 2 points level with the base of the crane at B. Okay, so we've got to find that angle X. Where is going to be our first step? Do we have any matching pairs? What can we do? Okay, so first of all, I do have a matching pair. 40 degrees matches with 60. So that would mean 80 would match with this one here, wouldn't it? Okay, so I can use straight away, we should see a matching pairs like this, we should think sine rule. And if we want the angle, I know that sine of the angle B over the opposite matching pair, which is 80, equals sine of 40 over 60. Okay, so when I rearrange this, I get angle B equals 58.986, blah, 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 blah. If I just round this to the nearest whole number, okay, because it doesn't give me any assumptions, so I'm just going to round this to 59 degrees. Okay, so this is 59 degrees. Okay, we know that we have 40 degrees, 59 degrees, and angles in a triangle add up to 180. So this one here, 40 plus 59 is 99. Okay, so this one is 81 degrees. Now, looking at this, okay, this doesn't really look right, does it? Okay, because first of all, this one really is an obtuse angle, and that does not look like 81 degrees, okay? So when it asks about the assumptions, we're assuming that the angle is obtuse, because now I'm going to change this to an obtuse angle, okay? So we know for sine, okay, when we draw our graph of sine, okay, this is 180, 360, 0. If we think, we know it's 59 degrees, which is about here, okay? But also at this point, there is symmetrically, we're going to do 180 minus 59, which is 121 degrees. Okay, so what we're going to do is, this one is actually 121 degrees. 121 degrees plus 40 degrees is 161 degrees. So this one is 19 degrees. And that looks better now that we've made the assumption it is obtuse. Okay, so once we have this, we want to find the angle x. What I'm going to do is I'm going to draw this out again, okay? So I'm going to draw this triangle out again, okay? And we know that this is 80, okay? We know this is 40 degrees. We know this is 19 plus x. Okay, and then this one, this angle here, is in fact going to be 180 minus 19 minus 40 minus x, which is 59. 180 minus 59 is 121 minus x. Okay, so that's going to give us 180 degrees. So far, this is what we've got. We need to find x. Okay, so now that we've found the angle, even though we've done this, it doesn't give us any help, okay? So, you know, at least we've tried it. But because it tells us that this is a wrecking ball, this line, okay, and it passes the 2 points level with the base. This isn't actually an isosceles triangle, okay? The lengths never change, okay? So we now know then x is going to be, this is 121, so this must be 59 degrees, remember? This is no longer, because 121 plus 180 angles on a straight line. This will be 59 degrees. 59 plus 59 is 118, okay? So x equals 42 degrees. Maths went completely wrong there. Should be 62. 62 degrees, because we've got 180 minus 119, 18. Perfect, 62 degrees. So we're also assuming, because we've said this is isosceles, because the swing is going to be completely symmetrical on either side. Okay then, so if we have a non-right angle triangle, the area is really simple, a half AB sine C. So remember, we're always going to use substitution, so the area is a half bracket A, which is 3, bracket B, which is 7, sine of the angle, which is 59 degrees. Now, I know that whenever we've been finding our angle, we've always called this angle A, okay? Again, you need to just get used to, if this is now angle C, so this is little a and this is little b, okay? But basically, if you've got the angle in between two lengths, you can always find the area, okay? And it's just the angle multiplied by the two lengths. So you should get 0.5 times 3 times 7 times sine of 59 degrees. And the area is going to be 9 to 3 significant figures. And it's, please remember the units, it's 9 centimetres squared. Okay, so then, nice and easy. You've got 2 questions to test your understanding. Off you go. Okay, so for the first one, we know our angle is 30 and our A and B are here. I always like to label everything so I know what's going where. So I'm going to half lots of A, which is x, lots of B, which is x plus 3, lots of sine 30. Okay, so I know that, now you may have expanded this a different way, okay? First thing I'm going to do is I'm going to put sine 30 into my calculator, okay? It is a half. You will learn to know that it is a half soon, okay? So I've actually got a half lots of x plus 3, lots of a half, because sine 30 is a half. Okay, now me being myself and how I work, what I would do is I would put everything over 4, okay, because a half times a half is a quarter, and then I would multiply this out. So I'm going to get x squared and plus 3x over 4. This equals the area which told us is 10. I can now multiply everything by 4 to get x squared plus 3x equals 40. I'm going to get x squared plus 3x minus 40 equals 0, okay? I'm then going to get x plus 8, x minus 5 equals 0, so x equals minus 8, or x equals 5. Okay, I'm going to reject minus 8 because here I have an x, and this would mean that this length is minus 8. We can't have a negative length. So I'm going to reject minus 8. So the answer is x equals 5. Okay then, here we go. So, again, this is my angle C, my A and my B. So I've got a half A times B times sine of my angle equals 10. Okay? A half AB, well, a half times 6 times 5, so I get 15. Sine theta equals 10. So sine theta equals 10 over 15. Okay, so to find theta, I'm going to do sine to the minus 1, 10 over 15, which is 2 over 3. Shift sine, 10 over 15. And I get theta equals 41.81 degrees. Now it said theta is obtuse, okay? So we know we love to draw the sine graph. Okay, so here's our sine graph. Remember, it's between 1 and minus 1. Okay, this is our 180, 360. Okay, if you think 41 degrees is roughly here, if I go up, you see it crosses at this point, it also crosses at this point. So it's 180 minus 41.81 degrees is 138.12 to 2 decimal places. Okay? Another way, you know, it's a bit of a rule really. If you're trying to find the obtuse angle, okay, for the sine graph, if you've got an angle which is 41 degrees, okay, if you have an angle less than 90, to find the obtuse of it, you always do 180 minus that angle. Okay, it's like a little rule for you. But we need to understand why, because as I said, later in this chapter, we're going to be looking at transforming trig graphs. So we're going to be drawing these and transforming them and solving them. Okay, but it is a rule, it is 180 minus, but we need to know why. We can't just use the rule. sorry everyone, sine of 32 over 3 is going to equal sine of our unknown angle A over 4, okay? Okay, so what I'm going to have is, if I put it over here, I'm going to get sine of A equals sine of 32 over 3 multiplied by 4. Okay, so I put that into my calculator. Sine of 32 over 3 oh, wait there, my calculator. 4 times sine of 32 over 3 is going to give me sine of A equals 0.706, blah, blah, blah. So then shift sign, answer, because remember we always want to keep everything as exact as possible. I'm going to get my angle A equals 44.95. For this, I'm just going to round it to the nearest whole number, so 45. So we've just worked out that this is 45 degrees. Now, I now know that angles in a triangle add up to 180. So 45 plus 32, we know is 77. 180 minus is 103. So I now know this is 103 degrees. Now that I know that, I can use my sine rule again. I have two matching pairs. So I've got these two or these two. It doesn't matter which one I use. I will get the same answer. I'm going to pick the blue matching pair that we had in the question. So we want to find x. So we know that x over our opposite angle, sine 103, equals 3 over sine 32. So x is going to equal 3 over sine 32 times sine of 103. So I'm going to get 3 over sine 32 times sine of 103 is x equals 5.51, and to the nearest whole number is going to be 6. Well, we could just use 5.51. So x equals 5.51. So the sine graph, as we know, we have our x-axis and our y-axis. Now, I always draw my graph and then fill in the axes, okay? You know that Miss isn't one of the best drawers. So I know it's going to go up and down. Perfect. The maximum point of the graph here is at 1, and the minimum point is at -1. Okay, here, which is going to be completely symmetrical, the midway point, this is at 90 degrees. This is 180 degrees. This is 270 degrees and 360 degrees. Okay, this is one term. Okay, this is one period. What we actually find is this goes on forever. So you need to memorize that if you don't already do. Okay, this is the graph of y equals sine x. So when we were looking at obtuse angles previously, you know, we had to find the symmetrical of the graph. Now, personally, I don't like using symmetry. I like to use the unit circle. For pure 1, we will be using symmetry, and for pure 2, we will be introducing you to the unit circle, okay? So here we have our sine graph, and as you can see, we have one period here, which is what the bit we know, and then it goes on forever. Okay? So sine of 150, okay, so if I find 150, it's about here, isn't it? This is 150, and if I go up, it crosses here on this line. And what I find is that there are going to be multiple solutions, aren't they? Okay, and the multiple solutions are when sine of 50, this is actually a half, okay? You can put that into your calculator, sine of 150, and you'll get the answer a half. And also, if you're 30 away from 180 here, by using symmetry, if we go 30 here, that means that sine of 150 equals the sine of 30, which also equals a half. So if you put in your calculator sine of 150, you'll get a half. Sine of 30 will give you a half. Both of those values will give you a half. Sine of negative 30. What is sine of negative 30? Exactly, it's going to give us negative a half, but negative 30, okay, is about here, isn't it? And if we go across, we're going to get, this is negative a half, okay? What else would give us negative a half? And that would be sine of negative 150 gives me negative a half. Okay, how about sine of 210? 210 is roughly here, isn't it? If I go down, I know it's going to give me a negative value. Okay, what is sine of 210, please? It's also negative a half, because if we carried on going, you can see there are many solutions, positive and negative. So that gives me negative a half. And actually, what else gives me negative a half is going to be sine of 330. Okay? Right, Kate's just said an amazing question. Kate said, but Miss, why don't you just put it into your calculator? What's the point in even doing this? Well, sometimes, Kate, when you put this into your calculator, you do not want, so if you put into your calculator inverse sine of a half. Inverse sine of a half. If you put that into your calculator, so we're going to do sine minus 1 of a half. What do we get? 30. We get 30 degrees. Okay, that's great that we get 30 degrees, but I don't want 30 degrees because the question says it's an obtuse angle. So I'm going to do 180 minus for it to be obtuse, which is great. So I also know that 150 gives me that. Then, for some random reason, okay, the question says, well, I say random. No, this isn't random. This is what I'm asking. The question says, what is the first negative value of x that would give us, I just realised, sorry, this has completely thrown me off. No one told me here. Right, what is the first negative value of x when y is a half? Okay, how are you going to figure that out? It is going to be negative 210. Okay, but your calculator's not going to tell you that, is it? This is why we're looking at symmetry of the graph. Okay, so normally with sine, we start here and go like this. Okay, cos cuts, it cuts halfway through, so it goes like this. Oh, terrible. No. Okay then, so this here is 360, 270, 180, 90. Our maximum is at 1 and our minimum is at -1. Okay? So, the relationship between cos and sine. Can anyone tell me what the relationship between cos and sine are? So, cos is actually a translation of sine. So, we know that sine of x is also, sorry, not sine of x, cos of x is in fact equal to sine of x plus 90. So we have cos of x equals sine of x plus 90. Again, you need to either learn this graph or know that it's a translation of the sine graph. And we're going to have a look later on in the chapter about this relationship, okay? So then, we have our cos graph. Here we have cos cuts. And if we put cos of 60 in, we get 0.5. But do you remember what I just said then? I just said that cos of x equals sine of x plus 90. So cos of 60 is the same as saying sine of 60 plus 90, which is sine of 150, which we know is a half. Okay, they have a very direct relationship. It's really beautiful. So we know that sine of 150 is a half, which is the same as cos of 60. So cos of 60 is about here. This is 60 degrees. And if you think, we go all the way along. Okay then, so in between here is 30 degrees. 270, it cuts here. So what do you think is also equal to a half on this side? It is 300. Okay, that's also equal to cos of 300 using symmetry. Okay, if you think between 60 to 90 is 30, this is also going to have to be a gap of 30. And remember, it's crossing the graph here, so I'm adding 30, and that's going to give me my half. If I go negative, this is also going to equal minus 60, because remember our gap is 30. And then if I keep going, it's also going to equal minus 300. But what happens of cos of 240? So cos of 240. 240 is about here, roughly. Okay. Now 240 has also got a gap of 30, hasn't it? So that means it's going to be negative a half, okay? All of these relationships we can find from the graph. Does anyone know what the tan graph looks like? Clear your whiteboards, please, and draw that for me. Okay, so here we go. Sorry, I forgot to record it, but we have asymptotes. But the most important part is this asymptote, the first one is at 90 degrees. The second one crosses at 180. The second asymptote, 270 degrees. And then 360 degrees. And obviously, the same pattern going forwards and backwards. There is no maximum or minimum. This goes on forever. Okay, so 1 could, for example, be here. This could also be 105. Okay, there is no maximum or minimum. So then, here's our wonderful tan graph. Okay, so if we did tan of minus 30 degrees. Minus 30 degrees is about here, yeah? Okay, and if I go down, it crosses here. From here, you can draw your line. We can also see that the answer for tan of minus 30 is also the same of tan, and if the gap's 30, what's this going to be? Tan of 150 degrees, which is also the same if this is 360 of tan 330 degrees. So if you put that into a calculator, shift tan minus 30, you should get minus 88.1. No, sorry, I did shift tan. That does not make any sense. Tan of minus 30 is minus root 3 over 3. Okay? What is tan of 150? Tan of 150, using our symmetry, should also be minus root 3 over 3. Okay? Again, this works for the, if we were to think, what is positive 30? So we know positive 30 is about here. This is going to give us tan of positive 30 is going to give us root 3 over 3 because it's completely symmetrical. So, question 1, sketch y equals 4 lots of sine x. What I always do is I think to myself, right, okay, I've got to do the sketch. It's a sine graph. Step 1, quick sketch of the sine graph to remind me what's going on. Okay, key points, this is 180, this is 360. You know this is 1 and minus 1. Okay, so sketch 4 lots of sine x. Is it inside or outside the bracket? Outside, and what I mean by inside or outside the bracket, this sine of x, this x is in the bracket. It's outside the bracket. Who does it affect? Y. And what do we do to all the y coordinates? We multiply them all by 4. Now, if I was to actually look at this graph and I think, where are my y coordinates? Because this is 0, 0, this is 0, this is 0. So I know it doesn't affect those 3 points. But my maximum here is actually, this is 91. And my minimum is 270, negative 1. So instead of them being 1 and negative 1, they're now going to be 4 and minus 4. So guess what, everyone? I'm going to draw my graph, okay, and I always start by drawing it. Guess what? This is still 180. This is still 0. This is still 360. But now, my maximum is 4, and my minimum is negative 4. Really simple. Okay, so if it was compared to this one, it'd go up to 4 and down to minus 4. But when you just draw a sketch, you don't really have to show exactly what's happened there. The next one is y equals cos of x plus 45. So I always start by drawing the graph, okay? And there it is. I know this is 360. I know this is 270. This is 180. This is 90. Okay, I know this is 1 and this is minus 1. So this is my sketch of the cos graph. And it says plus x plus 45. Is it inside or outside the bracket? Inside. Who does it affect? X. And what am I going to do to all my x coordinates? I'm going to minus 45 from them. So if some of you want to do this, you can. If you think this point here is 0, 1. This point here is 90, 0. This point here is 180, 0. And this point here is 360, 0. And this point here is... What has happened? Sorry, that's 270. That's... There we go. And that is 180 minus 1. So none of my y coordinates are going to be effective. It's only my x. I'm going to minus 45 from everything. So what my sketch is actually going to look like, okay, you can either plot the points. If you think this is now minus 45 and 1. So that's about there, yeah? Which is, that's where it's going to cut, okay? Then the next one was 90, 0, so that's going to be 45, 0. Okay? So you know this point is, instead of 0, 1, it's now minus 45, because 0 minus 45 is minus 45. Then the next point is here. Then the next point, instead of it being 180, is going to be 135 and minus 1. Okay? So you can see we've shifted the graph, right? So now, that's going to be down, up. It's going to look something like this, isn't it? And then what you have to do is you have to put the points in. So, for example, this point here, we know, is minus 45 and 0. We know that this point down here, sorry, not minus 45. is 45 and 0. This point here is 135 and -1. This point up here is -45 and 1. Okay, this point here, it was 270, it's now 225 and 0. And this point here, it was 360, it's now 315 and 1. Okay, and then it's about here, it's 360 degrees. Okay, so you can see how we've transformed it, and again it's a sketch, so it doesn't have to look completely correct, but we've also labelled everything, our x and y axes and all the coordinates that we know. So then, my tan graph looks like this, doesn't it? This is x, this is y, it goes up, my asymptote is at 90. I know it goes again. My midpoint's at 180, my asymptote is at 270, and then it looks like that. So that's what it looks like, and that's 360. It then says minus tan of x. So this is tan. Now negative tan, is it inside or outside the bracket? Outside. So who's it going to affect? Y. Now, if it affects y, believe it or not, okay, if it's outside the bracket and it affects y, it's actually a reflection in the x-axis, okay? We multiply all of my y values by minus 1, and it's a reflection. So actually what we do, imagine we had, oh my, imagine we had a mirror in this line, yeah? This is your mirror line because it's a reflection. So it very clearly states it wants the graph only between 0 and 360. Okay, you have to watch out. Sometimes it wants it between -180 and 80. So this is my y, this is my x, and it's clearly said it wants a reflection. So the first bit, you can see it goes up like this. Well, imagine if all your y values, so it's going to go like this, and your asymptote is still going to be at 90. Then this one is going to look like this, and your asymptote is at 270, and then this is 180, and then lastly this is going to be like that, and this is 360 degrees. So then I know again x, y, my sine graph looks like this. I know this is 360. I know this is 270, 0. This is 1 and -1. Okay, I'm not going to put in 90 and 180 because I know it's in between. I draw my sine graph, great. Now I have a look at what the question is actually asking me to do. Now I always like to draw my sine graph, okay. It says x over 2, sine of x over 2. Okay, so inside or outside the bracket? Inside. Inside the bracket. Who does it affect? X. And what are we going to do to all of the x values? We're going to multiply them by 2. So if I think about this, if this is 270, sorry, why do I keep doing that today? This is 180. This is 180. I need to multiply this by 2 to give me 360. Okay, so actually, great news everyone. I only have to draw that part of the graph because the interval clearly states between 0 and 360. I now know that this point is 180. My graph still has a maximum of 1, and this point is 0.